Hi, welcome to the Shuko Math Lab differential equation problem solving section. So the problem we are going to work on today is like this: t times t squared plus 6 y prime minus 4t squared plus 3 y prime, y double prime, then y prime, and 6ty with the initial conditions and y2 equal to 2, y prime 2 equal to 2. Now, because this is the second order differential equation, so we expect we have two solutions. All the problem we did before, they typical give us one solution, say, hey, y1 is the solution for this um, differential equation, and then we will use the method like a reduction method or use Abel's formula to get my second solution. So for these problems here, they did not give us what will be the first solution. So in here, so we will use our best guess to see here. Okay, so what will be the first solution I can assume to work? So for this problem, I plan to use two videos to go over it. Why I need to use the two video? The first video, okay, so the first video, so I'm going to choose y1 is equal to the xr. The reason why I said is x to the r powers here. The reason why, because I see, oh, this is like a polynomial t times and a polynomial. So I probably will choose the xr and see, whether I can use this one and help me to get another solution. Then the second video here, I'm going to use this one. The general form is y1 is equal to the ax plus b. All right. The reason why I want ax squared plus b, right? The reason why I choose it because I see this term and this term here. Okay, so I would do first video with y equal to the xr will be my first guess. Then the second video will be y1 equal to ax squared plus b. And I want you to see, how easy and how difficult, if you choose the different solutions. We still can solve it to get the same solution, but one of them is very tedious. All right, so have a lot of algebra. So my first video, I will choose a simple x to the r's powers here to do that. Okay, so now let's take a look. Okay, like I said, in all the previous video we did, they give you the certain what is the solution for the first one. Then we derive the second solution. Now they did not give us any, so let me guess what is the first one and see it work or not. All right, so now I will try to do this one. Yeah, like I said, will be this video here. Okay, so when we do this, so because we say y, so we say the y, so here, let's see here. Okay. All right, so the y, okay, so here, this is the y1, like we say y1 equal to t, the r's power, right? So then the y1 prime will be r times t to the r minus 1. Then the y1 double prime going to be equal to the r times r minus 1 t to the r minus 2. See here. Then my differential equation is t squared plus 6 y double prime and minus 4t squared plus 3 y prime plus 6ty equal to 0. Let me check to see we copy correctly. So t squared plus 6 minus 4t. Okay, good. Okay, so now, all right, so I'm going to substitute what I got for the y1, y2, y prime, y double primes here, right? Okay, so maybe I will color coding that. So the y double prime here, right? So y double prime is the r, the t minus 2. So I'm substitute here. Okay, so here that will be t square plus 6. Then my y double prime times r minus 1 and times the t r minus 2. Okay, so this is how I substitute my y double prime. Okay, then minus, okay, minus 4 t squared plus 3. Now I will substitute y prime here. Let me use a different color. So y prime is here, right? The first derivative. Okay, so now let's see here. So 4t squared times the r times the t, the r minus 1. Then the last one is substitute my y1, so it's 6t, and then y1 is just a tr. Okay, so just be very careful. So this is my y prime, and this is the one. This is the one. Is my original function tr's here. So then we know this. Okay, so then we know this differential equation going to be equal 0 here. Okay, now let me simplify this a little bit. Okay, so the t squared times, so these two I will combine to the t cube plus 6t. Okay, so now this is t to the r minus 2. I just rearrange it a little bit. R minus 1. Okay, minus 4t. So minus here is 4t squared plus 12. And then I have t, the r times t, the r minus 1. Then plus 6t. This is r plus 1. Equal to 0, right? Okay, so now I continue to simplify here, okay? So now in here, I'm going to do the distributive property here. Okay, so the first one going to have r minus 1, t to the r minus 2 times t to the 3 will have t, the r plus 1, correct? And then the 6th, so then plus 6r, r minus 1, and then t times r minus 2 will give me t, the r minus 1, okay? Then minus, okay, the same distributive property, 4t times r, so it will be minus 4r, then t is r minus 1, then here is t squared, so I have 4r times t, the r plus 1, okay, then minus 12r t, the r minus 1, okay, plus 6t r plus 1 equal to 0 here. Okay, so now take a look here. That I see the exponents only have r plus 1 and r minus 1, so I'm combining. So for all the components with the r plus 1, okay, so let me color coding that. Right, so the r plus 1s here will have this and this and this, right? Okay, so now I will do a combined them. So it will be r minus 1, minus 4r, and plus 6. Then for the remaining, I have a t, the r minus 1. So it will have a 6r, r minus 1, okay, minus 12r equal to 0. Okay, now I'm going to just a very tedious algebra. So it's r plus 1. Then this is r squared minus r minus 4r plus 6. Okay. And then this is plus t the r minus 1. So this is 6r squared minus 6r minus 12r equal to 0 here. Okay, so this will be r squared. So this one turned to be r squared minus 5r plus 6. And I can factor it to the r minus 2, r minus 3. And this one is 6r squared minus, the 18r. So for this one here, this is 6r squared minus 18r. So I can take the 6r out and factor that r minus 3. As you can see, I find something very good here. So both here, they have this factors here, right? Okay, so now what I can do is here, I can factor the r minus 3 out. Okay, so in here, the first term, this is t the r plus 1. So I still have r minus 2. Then plus 6r, right? 6r t the r minus 1 equal to 0. Because we know if you multiply two things equal to 0, one of them has to be zeros, right? So that is the beauty here. So finally, I would say good, r equal to 3. That means I can use my y1. So that means my y1, I can use t to the third powers here. Okay, so now let's take a look. All right, so now after this one, I'm going to use the Abel's formula to get the, to get the second solutions here. Okay, so our differential equation is t squared plus 6 y double prime minus 4 t squared plus 3 y prime plus 6ty equal to 0. I will divide by, so t times t plus 6, t squared plus 6, so it's minus 4. This is t squared plus 3. This is t squared plus 6 y prime plus 6t. So this is t, and this is t squared plus 6, right? And this is y equal to 0. So we know this is the term, this is what is my PT terms here. Okay, so the first thing is here. Okay, so now apply the Abel's formulas here. So if you still remember, the formulas here is V, I should say the Y2. Okay, so let's put the formula in different color. So it's the Y2 equal to the Y1 T and the times this is y1t the square, then this is e to the negative pt dt. Okay, so now let's do this. Okay, so the first things here we want to do is e to the, so let's okay, so we want to do the numerator. So we want to do negative pt dt. All right, so the pt is negative 4t squared plus 3. So this negative cancel out. So this one really is just you want to do the integration of what? 4t squared plus 3. And the t All right, so in the t, and this is a t squared plus 6 dt. So for this ones here, in order to solve this one, this is let's try to, like I said, so this ones here, we can use partial fractions, right? So I can divide this one is like t squared plus 6. So this is the a, this is bt plus c. So then we will have the t squared plus 6, at squared plus 6a plus bt squared plus ct. Right? So this is a partial fraction method in the integration. Right? So now you compare to the 4t squared. So I know a plus b is equal to 4, right? So that's the constant 4. Then let's know t terms. So ct equal to 0. So I know c equal to 0. And then the other term, the 6a equal to 12. So what I have here, so I will have a equal to what? I'm going to have a equal to 2 here. All right. So now this integration, I can just write as this one is 2t dt. Okay. So if a equal to 2, a plus b equal to 4, so b is equal to 2, right? So then plus, so b equal to 2 is 2t, c equal to 0, right? So this is t squared plus 6 dt. And what is this number? This is 2 natural log x. I'm sorry, natural log t, because the t don't need to put an absolute value because let's say t is greater than 0. All right, so here this is a t. Then the second one is here. This one is the natural log t squared plus 6. The reason why in here you can use u sub, right? So you say u sub, you can say u is equal to the t squared plus 6 du equal to 2t dt. That's why you get the natural log t squared plus 6. So this problem uses like a several integration skill. Okay. So now then you plus what? You plus the c1s, right? So this things here you can change it to natural log t squared plus natural log t squared plus 6 plus c1. So this will be the natural log t squared plus 6 plus c1. Now put e, all right? So now the e, the negative pt dt will just be the e, the natural log t squared plus 6 plus c1. So it's equal to t squared plus 6 times c1. So e to the c1, you can assign another constant, just like, you can say this is the c1 here, right? Okay, now after that, now I'm going to find the y2. So I need to follow the formula, right? So the next step here, I'm going to use this t squared plus 6. I put the c1s here. On the buttons here is y1 squared. So it's y1 is, remember we just got it. Y1 is what? Y1 is t to the cube, right? Okay, so now I need to put the y1 square on the buttons here. All right, so here, let's see, the y1 square t to the cube. So this will be t to the 6 dt. Okay, so now I can simplify it. So the first term going to this is times. So t to the 4th. So this will be t to the square plus 6 t to the 4th dt. Okay, so now this will just be very simple integration. So this will be c times 1 over t squared. The integration will be negative 1 over t, right? Then the 6 over t fourths, the integration will be negative 2 over t cubed here. Okay, then plus your c2s here. All right. So now in here, you can break it. So this will be the C1 times negative 1 over T minus 2 to T3. Then C1 times C2, you can give another constant. It's called the C2. All right, so finally, my Y2 will be equal to Y1. So will be T3 times what we just find. So it's C1 negative 1 over T minus 2 T cube plus C2 here. All right. Okay, now let me do a little bit of simplifications here. C1. So this will be C1 T cube times 1 over T. So what is this one would be negative T squared. Then T cube over T cube is cancelled with minus 2. All right. Then you have the C2. So this is C2 T cube. Good. Okay, so now I need to put my initial condition. All right, so this is my Y2. Okay, so let me highlight it because this will be what my final answer. I need to put it into here. Okay, all right, so now let's do it. So Y2 prime. All right, so Y2 prime will be the C1 negative 2T plus 3C2 T to the square. All right. So now my initial condition is 2 equal to 2. Then the y2 prime, the 2 equal to 4, right? So now I need to solve in the C1, C2. Okay, so y2. Okay, so y2 is C1. So it's C1 times 2. 2 to the square is 4. Negative 6 plus a C2 equal to 2. Or if you want to simplify it a little bit, so negative 3C1 plus 4C2 equal to 1. Okay, now plug it into the, the first derivative, 2. So it's a negative 4C1, 2. 2 to the square is 4 plus 12C2 equal to 4. Right? Okay, so let's simplify this a little bit. So it will give me what? Negative C1. So this will give me negative C1 plus 3C2 is equal to 1. Okay? All right, so now let's try to solve it. So this one should be pretty easy to solve. So in order to solve it, I can times the negative 3 here. Okay, so if I times negative 3, this will be 3C1 minus 9C2 is equal to negative 3. Now I add to this equation, so I will get a C2. Okay, I will get a C2 is equal to, so should I say negative 5C2 is equal to the negative 2. So C2 is equal to the 2 over 5. Okay, highlight it because we're going to use it later. Okay, so highlight C2. Now C1 is here. You just substitute back. So the the C1, so negative C1 equal to 1 plus 3C2, right? So negative C1 plus 3C2, so it's 6 over 5 is equal to 1. So that means C1 is equal to what? 1/5. Finally, okay, so now we find my second solution. Just plug it in to this pink highlighter I have here. All right, so let's see here. So my y2, okay, so my y2 is the C1, right? So my y2 is the C1, okay, so this is 1/5. You can put a negative sign here, and this is a t squared plus 2. And C2 is 2/5. So plus 2/5 of the T3. Wow, finally. Okay, so this is our final answer. All right, so now I know I can choose, the first solution be the T to the R. Okay, so like I said, I'm going to have a second video. I want you to compare to see the complexity, for the different methods here. So this is one, I choose the T equal to R, Y1 equal to, I'm sorry, this I should have said XR, TR is not the X. Okay. So be careful, this is T, is not, okay, X. Yeah, sometimes we gotta be careful. So this is XR, TR, I'm sorry, TR, and A the T squared because all the values here is T. All right. Okay, so my next video, we're going to talk about the method number 2. Because I see this t squared plus 6, then if I start to decide to choose y1 equal to the at squared, then let's see what happens here. And also, if I want to use the reduction method for that, then let's see. Are we going to get the same answer? And absolutely, we should get the same answers here. Done. All right, that's it. And I hope this problem can help you to start working on the differential equation. If later not give you the first solution, how do you reasonably guess what type of the first solution will be? And then you use the Abel's formula, or you can use the reduction method to find your final solution. All right, that's it. You guys have a good day, okay? And I'm going to talk to you next time. Okay, bye-bye.